Today we're going to solve ordinary differential equations in Matlab. We'll start with a function that we're given, something like theta double dot plus 2.04 theta dot plus 34.8 theta equals minus 26.9 delta E. Some function we're given. Our job is to solve for the solution theta of t for a given input or forcing function delta E of t. We're going to use Matlab's built-in ode45 command. This is going to require a function file to be built. We can access ode45 from either the command window or an M file. So Matlab's built-in command ode45 expects your function in a certain format, and it wants y prime as a function of time and y, or equivalently y dot if we're dealing with time derivatives as a function of time and y. We have a second order differential equation, theta double dot, but luckily we can make a vector function that involves theta dot and theta. So we'll define some intermediate variables, let y1 equal theta and y2 equal theta dot. We can then build this vector function y. It's just y1, y2, or how we've defined it, theta and theta dot. We can take the derivative of a vector function. It's just the derivative of the individual elements, so y1 dot, y2 dot, which is then theta dot and theta double dot. Solve equation 1 for theta double dot, and we'll use that to build our final function. So theta double dot, just solving equation 1 above, is minus 2.04 theta dot minus 34.8 theta minus 26.9 delta E. We'll just call that equation 2, and now we can use that to build y dot function, theta dot, theta double dot, and the top row here will just basically give us theta dot equals theta dot, and the bottom row here is what we're going to use this equation 2 to fill in. So theta double dot equals minus 34.8 times theta minus 2.04 theta dot minus 26.9 delta E. Let's check the math using matrix multiplication on the next slide. So solve for theta dot. How do you do that? It's just 0 times theta plus 1 times theta dot plus 0 times delta E, and that math checks. Theta dot equals theta dot. Solve for theta double dot. Minus 34.8 times theta minus 2.04 times theta dot minus 26.9 times delta E, and yes, that matches equation 2, so we're good to go. Let's go ahead and clean up the function a bit, because we do have a constant matrix A and a constant matrix B that are multiplying y and delta E, so we can just define those matrices. They're constant coefficients for all time, so it'll help us clean up our function. The only thing we need now is our input or forcing function. We get to choose it, or the mission will specify it. For our example, we'll choose it to be a constant. In other words, delta E over all time is just going to be minus 0.0349, which corresponds to a 2-degree elevator input. We're also going to need two boundary conditions. We get to choose them, or our mission will specify them. In our example, we'll choose it. We'll start our whole system from rest. In other words, theta at time 0 is 0, and theta dot at time 0 is also 0. Alright, let's bring up Matlab. Always good to do the help function. Help ode45 shows us what the function is looking for. So we get an output time vector and an output y matrix. ode45 is the command. We're going to need to build our ode function, a time span, and an initial condition on our y vector. Time span is just the initial time to the final time, so how long we want to integrate the system. And then y0 is our initial conditions. Okay, let's bring up how that works. A function file in Matlab starts with the word function on line 1. After you type function, it will turn the font to blue, and then this is the output of the function, which will be y prime. F16 underscore pitch underscore model is the name of the function. I can name this thing anything I want. And then t and y are the inputs to the function. So that's the number 1 line. And then we just have to build our function with whatever commands we want. Our input can be a function of time, but in our case we chose it to be constant overall time. But if it changed over time, you would just put some logic here. Depending on what the time value is, you would change the input with if-then logic. But in our case, it's constant. Here's our A matrix and B matrix that we formed on the PowerPoint charts, so that checks. And then all we do is build it. Y prime is A times Y plus B times delta E, just like we did on the PowerPoint charts. That's the function file. We saved it. It's ready to go. ode45 can now call it. I can do this from an M file or from the command line, either way. But here's an M file. It takes 1, 2, or 3 simple commands. You can group these together, or just like I did here, 3 separate. Build the time span vector 0 to 6. Build our initial conditions. We did 0 and 0, and then use that standard T, Y are the outputs of ode45. ode45 is the Matlab command. This is important. Put the @ symbol before the name of your function file. So @F16 pitch model was the name of our function file. T-span we just defined up here, and our initial conditions we just defined up here. All the rest of this stuff is plotting the output. So really, the meat of this shell file is what I call it, or M file, is these 3 lines right here. Everything else is just plotting. So I do have a vector function, theta and theta dot. So the first column of data, the colon just means any row but the first column, corresponds to theta. The second column of the output of Y is Y2 or theta dot. So figure 1 is going to plot theta versus time. Figure 2 will plot theta dot versus time. Let's go ahead and run it and see how it works. You can hit the run button here, or you can type it from the command window. We'll just hit the run button here, and just like that, it's done. Here's figure 2, which is theta dot versus time. Figure 1 is theta versus time. Like I said, I could also just copy this directly into the command window. I could put the time span vector directly in here, 0, 6, and the initial condition vector directly in here, and run the file, and it runs. There's the 2 columns of Y output. So the first column is theta, the second column is theta dot, and then if I wanted to plot time Y colon comma 1, it gives me the theta versus time, and I could obviously pretty it up with axis labels and such. So that basically is how you use ode45.